So the recording stopped suddenly. So we're kind of going back to the beginning. No, not really. We're going to continue where we were and move into talking about testing on the server. Okay. So we kind of took a quick look at the project for today and the project in the afternoon. All you have to do is pick any resource, whatever you want, and create a couple of endpoints for creating and deleting that resource. And then you're going to write some tests for those. And if you're done early, you are going into build week, so there may be a lot of work for you to do to prepare for build weeks, or maybe just take a break. Okay, so it's okay if you do that. I would suggest, though, that before you go and take a break and go work on build weeks, you kind of practice what we're going to see on the second hour of the lecture today. We're going to see something else not related to testing. So I would say go and practice that and then move on to something else. So that's the project for today. There were no questions because it's pretty simple. Pick something and just create and delete. Now, for testing on the server side, we're gonna see how to test at least 3 things, right? And it's pretty simple to do. In most cases, you don't even need Jest, but we're gonna bring it in, and we're gonna bring Jest just to continue working with the same syntax that you have used so far, because some cases will require that you go deeper than just using the library that we're using for the server. The library we're going to be using for the server is called SuperTest. I think that's the link to this on Training Kit. Okay. So take a look at it, and there are some quick examples of things that you can do there. We're gonna see it in the context of using it together with Jest. So some of the things that you see have shortcuts, we're probably gonna use Jest for those, just to continue practicing Jest. All right? So what do we test when we're working on the server would be the next step on this. Errors with the environment. Do this, okay, just to see if that fixes it. Stop the server. Make sure that everything is saved. Stop the server and run it again. If you still have problems after that, we'll see what happens when we go to testing, and then we troubleshoot that there. Let's get into testing. Forget about the environment. Know that yarn test is gonna work with a separate database, okay? Because we can't spend the morning talking about environments. It's not gonna go well for you. Let's go into the testing portion, and if you're still getting data on the database, then we go and figure out what's going on there. Okay. All right, so I have yarn test running here. Server is running there, and we don't even need to have the server running. I'm just going to stop the server. So we have the servers running, the test running here, and we're going to be using SuperTest. And basically, we're going to check for 3 things, okay? And the 3 things are, what is the status code that we get from an endpoint? Because at the end of the day, if we go look at some notes, I think there are some notes in here that we could kind of piggyback on. Yeah, there are. When we started this journey testing a function that we could pass some data, some argument, and that's going to return something. So what we do is we execute, we invoke the function, pass it some data, and check that what we get back from calling that function is what we expected. Now, when we moved into component testing, we do the same thing, only that worked with a component. So we had a component that takes some optional data in the form of props, and then it's gonna return some UI. Again, just give you a response. So what do? Well, we render the component, we pass in some optional data, and we check the UI. We check that the response was correct. When you move to the API, it's the same thing, but instead of having functions or component, you have endpoints. So what do? You execute that endpoint by using some kind of client. You call that endpoint, you pass it some data, and then you get a response back. So if you think about it, everything here is just like a function. It's the same thing, like everything in life, right? You have this thing that you do, you could pass it some input, and then you get a response back. So super test is really, really good for testing that, for testing the endpoint. So instead of having you to manually open up Insomnia or Postman, hitting the endpoint, passing some data in the body, you could do all that, but automatically with testing. Okay. So what do you test? Well, you could test, of course, the routes and the endpoints. You could test the business logic, but business logic, if it's not inside of a route, will probably be on a regular JavaScript file. So if you have a regular JavaScript file, how would you test it? Well, the same way that we tested on day one, on Monday. Export the methods that you want to test and pass the data and run them, right? So nothing fancy there. You don't even need a framework other than Jest for that. What about the data access? Well, the data access is a little different because we have been concentrating on unit testing. When you're doing data access logic, you're going all the way to the database. So this is more like an end-to-end for the API, where you do testing from all the way from the beginning, you're hitting an endpoint, but then you go all the way to the database and back. So when you get the response back, you're looking at the data from the database. Now, when you write that, normally in your test, you say, I'm going to try to insert some data. Let's say we're going to write a test for inserting data. And how would you normally check for that? Well, you call the endpoint, pass the data. The endpoint tells you, yeah, I saved the data. You go and check the database. You trust, right? You trust, but you go and test. You go and check that the data is on the database. We are going to do the same thing. We're going to call the endpoint, pass some data, and then we're going to go and check directly on the database to see if the data is there, to make sure that our routes are doing the right, are connected to the database correctly. That's the plan for today. Now, the first stop to doing this is we need to set the environment to running Node instead of the browser, because Node.js is running directly on your operating system, while the code that you run in the browser is going to run on the JavaScript virtual machine inside of the browser. So there are some browser APIs that you don't necessarily have, like there is no local storage because that's a browser API. There is no window object because there is no window on your operating system. That window object is called global in the Node environment. So we need to tell our test, we need to tell Jest, hey Jest, I'm not running in the browser anymore. I don't need any of that browser related stuff. Give me the Node related things. And it's really simple to do. So this is going to be the first major change that you do to your file now. And I'm going to stop for you to do it. So we're going to add into our package.json another key down here called Jest. And this is for configuring Jest. And this is going to be an object that could have quite a few properties in it. The one that we care about right now is test environment. And we're going to tell it by default, you don't have, if you don't add it, it's going to use something called JS-DOM. And that means I'm going to give you an environment that looks exactly like the browser. But we want this to look now like Node. So step one to make this work is we're going to change Jest to give us an environment that looks like Node.js. After you do this change, you're going to stop the tests if you were running them and then run them again. So nothing should fail. If I do that, it should tell me nothing changed. Your job is go and do that, right? Just no, switch to Node, okay? Switch to Node. That's the first step. Okay, we're good to go. Let's write the simplest possible test that we can write. So I'm going to look at server spec.js and also look at server down here. Right? We're going to test a few things. So the first one is, how can I see? And remember, we're going to be testing the endpoints, testing endpoints. Returns correct HTTP status code. Endpoints. Returns the correct HTTP status code. That's an easy one. So just it's going to be my server.js. And then it returns, and of course, now that I think about it, maybe we want to have an estes describe here to say I'm going to be testing the slash endpoint, right? So it's going to be get to slash. That's what I'm testing now. That we can do this get to slash. And it's going to return the correct status code. Now we write the test. Again, not that, but this. Why am I hitting that weird G next to the T? Oh, I know why. All right. So returns, what should this test be? Like it should respond with 200 OK. Okay, respond. And that's our test. Now, we mentioned the library, super test. So we need to install it. If it's not installed in your computer, you of course need to bring in that package. So let's go and add yarn add super test as a dev dependency. So you can bring it in at the top of this file and use it to make that request to my server. Cool. So let's bring it in. They call it request, so we're gonna do the same thing, but I don't think the naming is important here, right? You can call it whatever you want, but if you wanna go in line with their documentation for the examples, let's call it request. It's unfortunate because there is a request module on Node, but they decided to do that. Anyway, so super test, and we call that request, okay? Now, we're gonna be testing the server, so it's probably a good idea to go and bring in the server because it is the system under test. Oh, wow. The server.js. Now, if you're testing this manually, this is what you would do. You would open up your client, go to localhost / making a GET request, hit send, and then, oh, the server is not running? Yeah, server should be running for the test. But this is what you would do. And then you would check, am I getting the correct HTTP status code? That's what you would do manually. So we're going to do exactly the same thing. We're going to say, I'd like to make a request, okay, request, and this is the library doing it now, to, or using, is that probably the correct term, using my server, okay, this server that I imported here. And what I want to do on that server is a GET request to slash, okay? Now, this endpoint is going to return what? What is it that we get back? All of those are correct, but ultimately, the first thing that should come to your mind is a promise, right? This is going to return a promise. So we need to handle that promise in order to check what's inside of the response. So then, and catch. Okay. Now then, in here, we're going to have the response from the server. And here, now we could check, we get access to our response, we could check whether the status code that we expected was 200. And of course, I'm going to show you shorthand for this using just the library, but I'm going to write this in the kind of jesty matter, right? Jest style. So now I could say, I expect that the response, and the response that we get back is going to have a few useful methods and properties in it. One of them is the status code. We could read it directly from there. Okay. So to be 200. I'm ignoring the catch for now because this is still not going to work the way that we expect it's going to work. Okay, so if we save that, run the server, and the reason is that this test is running and it's asynchronous, right? Because we have this promising here. So if we come here and change this to be 500, now I modified my server. Instead of returning a 200, it's returning a 500. And it still passes. But hey, it's not really 200, it's returning a 500. And the reason for that, and this is new learning here, when you have something that is asynchronous like this, you could handle it 3 ways. 3 ways using jest. The easiest by far is by giving jest the promise. Okay, so by far the easiest is, since I know that this call is going to return a promise, all I have to do is return that, give it back to Jess and say, hey, Jess, here's a promise. Jess is going to see that and is going to say, oh, this is a promise. I need to wait until the promise is resolved. And then I'm going to do my expectation. Make sense? So if you ever have those false passing tests, it's because and that happens to me a lot, because we forgot to return that promise. So now this is working the way that we expect, right? Now that we can see that, yeah, it's checking, and it actually waited to get the value back. So a gotcha there. Asynchronous tests, return the promise and give the promise back to Jess. Cool? Your turn, go and write that simple test to check for the status code. Make sure that it fails if you change this to be anything else other than 200. So that, to make sure that your test is actually testing the right thing. Do you see how important it is to have that red stage where you see the test fail? Because that could have been a false positive. You continue to write a lot of tests. Oh, everything is passing, everything is passing. No, it's not. You're just not testing it. You have to make sure that the test can fail. So give it a try, please, and let me know. Okay, we have 3 more people. Is it errors or is it just typing? Okay, cool. Good to go. No errors. Promising. There is a shorter version of this test. Okay, if you were not using Jest or you just want to have something shorter, you could use Supertest provides like a way to do this a little faster without even having to worry about Jest at all. So let me show you. Shortcut. If it's just status code, you can definitely use this. Okay, so you do the request to your server. Don't need to pass it anywhere because this is going to be tested right there by the same framework. Just do your get to it, and if you look at the example, you could chain on this get. I'm gonna get rid of all of this. When you do your get to the server, you could chain and expect right there, and I could say expect 200. Make it expect, well, 200. Let's make it 200 and run that. And this would be should work. Save that. So we have two different tests. Everything passes and everything's good. There we go. Should work, passes too. Now, what if I make this, let's say only run this one. Save that. So we only run one. And then we change this to be 500 instead to see if that fails. There you go. No. Oh, yeah. I lied, apparently. Did not update. There we go. There's what we see. Should work. Got 500. So again, no need to wait for the then and all any of that. Run the expect. You could just say expect 500, and you could do expects on other things like the content type and all that. Like if you look at the example, you could do content type like so. If you know what the headers are, use the names of the headers. But we're gonna do something a little simpler when it comes to checking for the content type. So two different ways to run the same code, basically, same test. Pick the one you like the most for the HTTP status code. Now, next test would be, is it JSON? Okay, because your API might be wired in such a way that you could return JSON or something called XML, which is a different format for sending data over the wire. Since we know that our API is designed to work with JSON, we want to check, make sure that we're always sending JSON back. Again, if all you send always is JSON, you're okay. But what if you're working on a project that needs to have both? And you need to pass an option that says, give me back XML. You want to make sure that when you call your endpoint and you say, give me XML, you're getting XML back, right? So how can I check for that? Well, you saw that you could check for the content type. But of course, as always, this framework has a shortcut for that. So I could say, should return JSON, right? So we're gonna say request. Go and make using my server, okay? And it's gonna spin up a new server every time. Do a get to slash, and then I'm gonna check in here that the response, gonna make it a little shorter now. I'm gonna expect that the response type, haha, to be application JSON. I know that's the type. This could also be like a regular expressions like that, like to have JSON in it. But in this case, I want to be a little more explicit. I want to make sure, just in case some company has some weird something that has JSON, I want to be explicit that the standard is application.json. Okay, like so. Let's try it out to see if that works. And it works. And what if I do this instead? Haha, because I don't know, maybe it works, maybe it doesn't. Because I want you to notice what is missing from that test. What if I do this instead and I send a string without JSON or anything, a string that says hello? Oh, still passing. Why is that? Because we're forgetting what? The return, right? Return. Remember, this is asynchronous. So we need to tell Jess, hey, wait until you got a response and then run your assertions. Now, this is telling the right thing. You wanted JSON, but we got text because I'm just returning a string, right? So now I know that it can fail. Now that I know that it can fail, I return JSON and see if that makes it pass. Making sense, Joshua? Tico? All right. So please go ahead and write a test, and that's your second test. Easy one. Make sure that it can fail before it passes. Should we always let Jess handle the async stuff? It's not that we should, it's that we have to. Otherwise, Jess cannot test for the response if it doesn't wait for it. You have to wait until you get the response so that I can run assertions against it. So can we shorten the application JSON test too? It's not gonna be really that short because you have to check for the content type. So it's gonna look like this instead. Let me show you. You say expect content type and then like so. It is shorter for sure, but not a lot shorter. It is shorter. Yeah, you're right. It is shorter. Well, not in this case. If you're using this, you don't need res or anything. It will look like that, like this test right there. Just copy this to write it an alternative here. So instead of expect, you need the content. And this is the header that says what the type is. And then I think it's JSON. Is it what is the syntax that they use? Yeah, just they're using just a regular. Again, they're using a regular expressions. You could use that with jest, but like so. Like the content type has JSON. Then you return that. That should work. If you do that, check for JSON. This is not using jest at all in this case. I mean, it's using jest to run the test and handle the promise and all that because you're returning the promise. But the actual assertion here is happening at the level of the library, of the super test library. Okay. So we're learning two things here. First, how to test the server, but we are also learning how to handle using jest because it's not always going to be when you're hitting an endpoint like that. You may be running any other asynchronous operation, maybe reading a file, and you want to test that. So if it's going to return a promise, whatever it is returning a promise, you need to return that to jest. That's one way of handling promises. That's the easiest by far. There are two more. The other way to making a test async is just by making this function async. So if I wanted to check, let's say for this one, in the other syntax, we could do it. Again, I don't want to go into, and the third one is using a callback called done. I don't want to go into all of those details because it's not going to help you because most of the time you're just going to be handling promises like that. So if you make this function async, I wish that I could have you kind of ignore this, but now I got into it. Now we no longer need to do all of this. Instead of returning, we could just say, you know, const response equals to await on this, on request server.get, And then since you are awaiting, you no longer need this. Okay, you could just run the expectation right after that. So it will look like that. Make the function async, and this is going to be async. Make the function async. Await on the response from doing the get to the server, and then you could check for the response status. Because this never runs until you await on it here. So this is the async await way of it. No need to return anything. I'm sure I'm sure that you want to see the third one. On the third one, you just get a done callback past it. I'm going to give you all three examples. Just learn the first one, using promises, don't concentrate on the other. So now we don't have async anymore. Okay, so instead we have a done function here. And this done function is useful because this is given by Jess to say, when you're done doing your thing, let me know, and then I'm going to run my assertions. So in this case, we don't have this await anymore. And then we go back to having our then. And notice that we're not returning anymore. And then we have our response, and then we call done. I think it's like that. Don't use that syntax much. See if I remember. Yeah. Because in this case, we're not returning anymore. I don't know if that's going to fail, though. So let's try it out. Rusty on this done syntax. So let's make sure that we can make it fail first. And 500. See if it fails. Yeah, so it checks for the 500. Without, the difference is that in this case, since we're using the done function to let Jess know, hey, I'm done, I'm in here, you can now run your expectations. You don't have to return the promise anymore. But then you need to remember to bring in done and call it. Otherwise, it's just going to take forever. So pick your poison, I guess, the style that you like the most, and go with that. Again, you have three examples there. Pick one, and unless you see a need for using the other ones, just stick to one of them. Don't practice those. You're gonna have the code, okay? Concentrate on just doing the stuff that we're doing here. I'm also gonna close this one. And this one. Now, we have tested two things about the endpoints. The third thing, because we're already in the hour and I want to stop here after this one. The other one is, what if I want to look into the actual response? Like in this case, what if I expect that by passing, I don't know, a value, I'm going to get a particular response back? Now this is going back to the concept of testing a pure function. If I pass an argument, I get something back. If I pass a different argument, I get a different response back. And I can now check for those. I could pass different data to my endpoints, knowing exactly what response you should get back, and you could go and see, is this the response that I got back? It's not enough that it's a 200. Is it what I expected? So in the case of this endpoint, it's simple, right? Because this endpoint is just checking that we get this object back, right? So let's go and check for that. Let's try to check here. If he wants to just there you go. It should return, I don't know, API running, I think. Is it API up? Like so. Simple test, but again, think of it as on something that you're doing a calculation and return some value back, and you pass different value, you should get different responses. So the same thing, right? We're going to return a request using our server. It's going to be a get request to our endpoint. And then in here, once we got that response, what can we, if I know that I'm going to get this object back, I could check on the response body, what matcher can I use for this? To be API up, right? Let's run that. And it fails with a weird error message. It's saying that API up is not the same as API up. Why is that? What can I do? How can I fix that? Yeah, to equal, right? Because they're different objects. But what's important here is that our test is checking the right thing. Cool. See how tests are a little slower because you're doing that asynchronous thing and Jess is waiting to get the response back? Yep. That's what happens when you do like integration testing. Is they are a little slower than simple just execute a function and get a response right away synchronously. So tests are going to get a little slower on end-to-end and also on integration tests. Kevin had an alternate syntax. Yeah, you could definitely do that. Or you could do this. So he says, what if I do body dot up to equal, to dot API to equal up? Yeah, of course, you could do that. For sure. Just wanted to kind of reinforce the idea of to be versus to equal. So the three things that we test, HTTP status code, that we get the correct response back by passing data, but we're not passing data. How can we pass data? Well, after the break, we're going to come back and we're going to test heading the endpoint that will, let's say, create a hobbit. So that we can now involve a database in the process, see if that saves the hobbit and gets the hobbit back. So in order to test that, we need to be able to pass data to our endpoints. So we'll do that when we come back. For now, I want you, because I know this is pretty kind of straightforward, I'm giving you temporarily this code while you get the zip file. This is the code that I have. Make sure that you can run it and test it without any problems. So I'll see you in 5. And we're back. All right. So hopefully everybody can run the test on the file that I just sent on Slack. Tell me yes if the test run. So basics of testing, endpoints. So what about testing? But I want to go all the way down to the database, and for that, I can get rid of this spec right there. For that, we're going to open our Hobbits folder. There's a Hobbits model and a Hobbits specs for the model. Okay, so let's have this be on the right here, and the specs are going to be on the left. Right. So there's nothing implemented here, and this happen to be async functions, but could be regular promises. Now we're going to bring in some tests on this side. So let's start by adding, of course, a describe if it wants to, doesn't. All right, Emmanuel. Okay, describe. This is going to be our Hobbits model. And then here, let's write tests for this insert function. So if I ask you, what would be the happy path there? Like if you're testing, what would you test? Happy path, testing the insert functionality. Yeah, that it returns a 201. That would be a very good one, right? Returns 201. What else? Because we could test that already on the endpoint. I want to test. Remember, this is not testing. This is good for the insert endpoint, but that's not what we really want to test. We want to test the model class at the end. Okay, so yeah, good. Returns 201 is perfect. Yeah, that it actually inserts the Hobbit, the resource, the Hobbit in this case. Okay, it has to do that, or it's not going to work, right? If it doesn't insert the Hobbit into the database, it just doesn't work. So, happy path. That's the easiest thing that we want to do. Okay, so let's go and write that. Again, we are testing the model, so we probably should bring in the model. Okay, so const hobbits is going to be equal to require that hobbits model, right? So make sure that we have the hobbits. Now that we have it, let's go and write a test like so, and say this is should insert the provided Hobbit. Probably a good idea since this is going to be the whole Hobbits model. So let's do a just D here and say this is going to be for the insert method. That's what we're testing. Because you're going to have tests for also the remove, the get all, defined by ID. They may all be in this file. So let's separate them. Okay. So how can we test this? Well, what you would probably do manually is you make a call to the endpoint, pass a Hobbit, and then you go and open the database and see that the Hobbit is there. Does that sound like a good plan to test this manually? Right? Ultimately, you want to check the database. Now, we do have a way to get access to the database, only that we don't have it in this file. So let's go and grab that. Let's go and grab a way so that we could programmatically go and check the database. So let's say that this is going to be my database, and you know where this is going. I'm going to require, there is a file there somewhere. Where's my, oh, that was running again. Okay, never mind. Sorry, there was some buzzing in my ear. So now there is a file out there, I think it's inside data, called dbconfig. And we could use this in order to get access to our database, right? Manually after we execute some code. Now, we can make this an await. Well, let's make an await to show you, right? And we could say hobbits that insert. I'm going to make it a wait, not an await, an async test, so that we don't have to be nesting the promises. Okay, but it could be with promises. You just need to nest them. So the method is called insert, and we want to pass in a hobbit. Okay, this is a good candidate for having our setup, where we say something like const the hobbit is going to be whatever, right? Since this is such a small entity, I'm going to pass it in line here. But if it's a large object, you probably want to create that object first and then just pass the reference to it. But this one only has a name, so I could get away with just having the name in here in line, okay? And we're adding the gaffer. Who's the gaffer? Async. Here we go. Sean is the gaffer. Okay, cool. So this executed our endpoint. Now let's run an assertion. And running an assertion means I need to go and look into the database and see that the hobbit is there. Okay, so let's do first one kind of simple. if we know, right, we said that we expect the test database to be empty, because when we're running the test, we are connecting to the test database, not the production database. So we have our server running, no, yarn server. If we do that, and we go /hobbits, okay, we have Sam, Frodo, Pippin, and Mary, but the gaffer is not there. This is connecting to our development database. So we're inserting this, okay? Cool. Remember, we're not doing things like requests or anything like that, because we're not testing from the endpoint point of view. This is testing from the model point of view, okay? No need for super test or anything. So if we call insert, what we should be getting back, and this is, well, we should be getting back null, but the point is that we should go into the table now and check that the data is there. So I'm going to say const, let's call it hobbits, right? Why not? Hobbits, lowercase, is equal to calling db, and again we can await db. This is so much cleaner with await. Hobbits, okay, and now I'm expecting that I'm going to get a collection of hobbits back. And if that's the case, I could check, well, I'm going to expect, simple test, that the hobbits have some data. 1. Well, there is a hobbit in that table. And nope. No. Totally empty. There's nothing in there. The table is totally empty. So we need to implement this, the insert, to make that test pass, okay? But this is the test right there. This is a way of writing this. We execute the function. Then we go and bring the data from the database from that same table and check, like in this case, is the first check that I have a record in there. Didn't work because this is not implemented. Let's go quickly implement this in the, we're not going to do any error caching or anything, just to make sure that we could actually add stuff in there. So I'm going to say return db hobbits dot insert. Well, I'm going to have you drive this. What is the command that I'm going to use? How can I add a hobbit into the database? Post. Funny, very funny. All right, insert, and then I'm going to pass in the hobbit, the provided hobbit. Okay. Very funny, very funny. Okay. All right, but what do I get back when I call insert? What is it that I get back? Yeah, you get an array that has a record that is an ID. So of course this is passing. But what if we do this now and we say the gaffer, Aragorn, and Gandalf. They're not hobbits, I know. Sorry, Aragorn, you're not a hobbit. Save that. Yeah, this is what I got out of all this. 4, but we are inserting 3, and we're still getting 4. That's weird. Let's see what we're getting. Const hobbits equal to this. Save that. Oh, look. And again, I want to run an exercise by you. I don't want you to answer, okay? I'm going to stop right here. And until I say go, don't hit enter, please. We are inserting 3 records, Gaffer, Aragorn, and you can see them right there. But we have 4. instead of 3, okay? We expected 1, but we're getting 7 now. Look at this, now it's 7. So if I go and check this is even different now, just because I kind of saved that. So let's do that. Shift Alt F instead of saving. Oh, what do you mean no? Okay, so you see how this is kind of, oh, look at that. There's more now. Oh, look, now it's gonna be 10 when it comes back here. Yeah, look, 10 instead of 1. Okay, so I want you, don't hit enter. Type, do you know why that's happening? Like, tell me why that's happening, and I'm gonna wait for you to kind of type that response, and wait until I say go. Few seconds, few seconds. Go! All right, let's see where we are. Yeah, yeah. Yes, that is correct. Yes, it is correct, right? The problem is that every time the test runs, is inserting 3 records. The first time it ran, it only had the gaffer. So this is why we only have like 1. And then after that, we always get 3 more and 3 more every time the test run, which is unfortunate. Tricksy hobbyists, yeah, for sure. So what is it that we want to do after each test run or before each test run? We need to have an empty test database. Now, here's a response to a question that I had earlier that said, why do I want to have 2 environments? Well, in this example, we want to have 2 environments because I want to have 2 different databases. I may have a database for development that has a lot of data, not only the hobbits. But I may want to have a test database that I can just wipe out every time so that I can guarantee that things like this don't happen, right? My development database, I don't want to be wiping it out all the time. Not necessarily. Might be the case, but not necessarily. But for the test, though, it's really, really important that each time the test run, you can predict and you can be sure that no other test has polluted your database. So what method, what global from Jest can I use to kind of clean the database before each test run? Do you remember that? What can I use for that? Yeah, so those are all good answers. Like it could be before each, it could be after each. And of course, you can have that anywhere, but the before each and the after each is going to run in the context of a describe. I'm going to do it. I'm going to say it again. The before each and after each, they're going to run into the context of a describe, which means that if I have a before each here, it's only going to run for this describe. If I add the before each here, it's only going to run for this describe. If it's okay that you only have 1 describe, that's fine. But let's say that I wanted to run I want to clean up the database before all of the tests, whether they insert, remove, get all, whatever, then it's probably a better idea to have that before each be outside, not inside of the insert. So instead of having it here, inside the insert describe, we're going to have it out here at the scope of the whole Hobbits model describe. So let's do it before each. I say before each, not that, but before each. We want to execute a function. Now, my question for you is, do you remember, in the case of next, is there anything that we could use that will quickly clean a database, including the IDs and everything, like the primary key, all of that gets kind of reset. Do you remember anything like that? Yeah, Next Cleaner does it, but a Next Cleaner is going to be really important when we move to Postgres or MySQL. But if you have your test database set up in a way that is not respecting primary keys, you could run a command that will wipe out the table. There's a SQL command, not drop it. That will delete the table. Unless you go and drop it and then create it. But there is a SQL command that you can run that will clean up the table, like all the records, delete them, and then reset the primary key. Yep. Gil has it. John Palacio has it. It's called truncate. So since we don't have any problems with primary key, and this is why SQLite shines when it comes to having like a test database, because we don't have to worry about kind of Next Cleaner or anything, right? We don't have to worry about those for our test database. We just want to be able to wipe out the table and insert data again. So in here, we can make this before each, just to make it a little cleaner. We can say, hey, make this an async to function, and then just do await here, and say db hobbits truncate. Boom. So before this test runs, every time, this little function is going to run. It is async. So it's going to wait, take db hobbits, truncate the table, and then the test runs. And then it truncates the table, and then the other test runs. Okay? It's lying. It's actually working. It's just the first time. Oh, but by the way, look at this. Oh, it's not lying. It actually gave me what we expected to see, right? So we wanted to see something like this. This is what we want. Well, I see that we only have, oh, I didn't copy the whole thing, sorry. But the point is that it's doing the right thing because we are inserting 3 records, and what we're getting back is 3 records. No matter how many times we run it, we're only going to get those 3 that we inserted. So yeah, that's fine. That's fine. But I don't want to change that yet. So when doing your test, it's really, really important that you clean up before you run each test. You clean the database. This is a simple way of doing it with SQLite. Now, if you're running this on a local instance of one of those servers, then you need to bring something like Next Cleaner for sure, right? So instead, you take that same command that we have for Next Cleaner, calling clean on it, and you would import it in here and then just run that in the before each. But it's the same. It's just using the other command that you have for that. Okay, so now we can test this and go and change it and say, hey, yeah, I inserted 3. I want to see 3 in there on that table. We're confident that nothing is polluting our table yet. Now everything passed. Now, what if I had 3 records on that table that were not these records that I'm doing here? So I'm going to write another test in here just to make it a little more, like, feel better about myself. Say insert the provided hobbit. This one is, I'm going to leave it as hobbits, right? This is going to be like insert the provided hobbit. And only do this. Take, say I'm going to insert the gaffer. And then what happens when I insert the gaffer? And then I'm going to insert Sam. Okay. So if I call insert in here and say let hobbit equals that, what am I going to get here? What is the response from that insert? It's going to be an ID, right? An array with an ID. So, but what I really want to know is, did I, like if I go into the hobbits table now that I know was empty, that's the first record, and say, give me the first record there. The only record that's there actually, because, right, that's the first record. Can I check that hobbit, oh, I don't even need this anymore. Let me get rid of this, okay, to make it less confusing. So if I go and grab the hobbit, what I want to say is I want to implement this so that when I do an insert, I get the hobbit back. Can I go and check and say the hobbit name to be Gaffer, and then insert Sam and do the same thing and say Sam, okay? And then say here, hobbit, right? This is why we made it a let, okay? So let hobbit equal to, insert that with Gaffer, check that the name of the hobbit is Gaffer, and then overwrite the hobbit and do another insert passing Sam and check that we have Sam now, okay? So now I'm checking, not necessarily going to the database, but I am checking that my insert command is returning the hobbit that was inserted back. But we get undefined because what we get back is an array that doesn't have a name property. So we need to implement this. We need to say, okay, so I'm going to insert this, and what I'm going to get back out of this is, yeah, first hobbit and all that. Yep, yep. Any reason not to put the before each in the global code? No reason in this case. It would work. You could put it out there. You don't need to because it will run here for all this tests, but yeah, it could be out there. So let's change this insert to implement this. Let's say instead of returning this, we want to return the hobbit actually. So we're going to say const, and again, I'm going to write it because I'm going to feel, because I know that you're familiar. I'm going to destructure this ID from this call right here, right, for the insert. Now I have that ID, and what I really want to return is return a call to the DB with hobbits, and I'm returning where this ID is the one that I got. Grab me the first record. Simple. Without the semicolon, please. Not need for the semicolon in there. There we go. That broke. Broke the tests. Syntax. Yeah. All right. So do I still have an error there? No, we're good. All right. So what is this? Is this? Oh, yeah. Any idea why this is a problem this way? Yeah, because it's not waiting for this to happen. So a good idea would be to say, I'll wait on this. This gets me a lot. Gets me all the time. So it went to return this, but didn't wait for the insert to happen. Now it passes. Okay. Now this makes me feel better because I could say if I insert Gaffer and I check for Sam, this test should fail, right? Right? Because I expected Sam, but I got the Gaffer. So, and if I insert Sam and I expect to get beeping, the test should fail. So now I know that I'm actually checking for the response coming back from that insert method, right? I expected beeping, but I got Sam back. I want questions about this. No need for you to follow along. Again, I'm going to grab the code and just give you the code. It's more the concepts that I'm expecting that you kind of grab the ideas. What if we're testing the delete? Well, if we're testing that remove method right there, I would insert a record, check that it's there, and then call the delete and check that the record is no longer there. So these tests tend to be a little slower because you're doing that, but you need to do that because if you're testing it manually, what would you do? You insert a record into the database, you go and check that the record is there, and then you call them the delete, and then you go and check that the record is not there. Only that we're doing it automatically here through code, but still it's going to take extra time. It's slower than everything else. This is why you concentrate normally in unit tests in your day-to-day, and then these are tests that you do later. And a lot of these tests happen automatically on something called a continuous integration system. So when you push, these tests run. So if they take a little more time, it's okay. We're stopping here, okay? For now. So we tested endpoints, and now we're testing a model, going to the database, spinning up a test database based on the environment. And we're cleaning up the database every time before we run the tests, so that we can run the test without any problems. And we see now that we can make more than one request. We make one, and then we make another one. And it's okay. Just don't make this a const. Make it like a let. All right, moving away from this. If you don't have any more questions, class is over. No, just kidding. Do you need to commit the test database to Git? If you want to. You don't have to, but if you don't commit it, you have to run migrations every time to create it, right? Because it's not created automatically. Test database, I would probably just commit it, just because it's going to be empty anyways. It's going to be really, really small. I don't see why not. Even the development database, if it's really small, why not? We'll just drop it there. Okay. Now, who has another like 35 minutes to stay with me and see something else? You don't have to, but let's begin. Now, go back to your browser. Okay, we're switching gears. Go back to your browser and go into Heroku. Okay, you have your fork of this, so you can push to your fork. Okay, go into Heroku, create a brand new app, give it any name that you want. I'm gonna call mine, Luis Hobbits. Hopefully that's not taken. Create the app. Okay, and then go into the deploy and connect it to your GitHub repository for this. So I don't think I have one here for this. I don't think I forked it. Oh no. Haha. Watch this, watch this, watch this. GitHub. Easy to solve problem. New repository. And this is gonna be called Hobbits. All right, so now that I have it, it's gonna be a public repository. We're not gonna add anything in there, no license, no README, nothing. But then I'm gonna copy the URL for this, and go into my terminal here. Easy fix, easy fix. Go into my terminal, stop the server, and they say git remote at mine or Hobbits. So I'm adding this repository was cloned from Lambda. So origin points to Lambda. I'm gonna create a brand new remote called Hobbits that is gonna point to my version of it. Haha. So now I could say git push to hobbits instead of to origin. And in there, it's gonna push to master. And if we go back to my repository now, should have all the code there. Haha. But now this is mine. This is not connecting to Lambda anymore. This is my own. I get green squares and everything for this. So now that I have that, I could go into the GitHub and say, find me something that has hobbits in it. And that would be this one that I just created, connected. Say automatic deploys and deploy this branch. You can go ahead and follow along, but do it with your fork and just push it. Okay. So if we go to overview, this is building. Kind of a quick review of how we did the deployment already. I know that you've been deploying every day, so you know this, right? Right? Tico smiling. It's like, of course, Luis, I do this every day. I deploy for fun. And it said that it's deployed. Let's hit open app. It says that the API is running. Let's go to /hobbits. Now, my question to you is, should I see data or should I see an empty array? We should see data. Let's see. Yep. Why is that? Yeah, because by default, it's running against the development DB. Excellent. It's no longer in a testing environment. Very good. So at least mine is working. Let's see if yours is working. And you don't need to implement the models for this to work because this endpoint is already built. It's part of the index. So it should show you some data. So yes, no, deployed. Again, quick review. Created a new app, went into the deploy tab here, clicked on GitHub, found my fork, in your case would be your fork, found my repository, hit connect, enable automatic deploys, and then click the deploy branch once to deploy from master. And went to /hobbits to make sure that it works. /hobbits. Looks like everybody is working. If you're not, please tell me because I'm going to move into something else now that is totally new information. So if you're still working on that, you may miss it. And I don't want you to miss it. This is going to be important for you. Because you're going into labs and then you're going into buildwigs and this is going to be really, really important. Really important information coming up. Yes, yes. If you deploy to Heroku as part of buildwigs, this is going to be really important to you. Mm-hmm. Yeah. If you have too many, I think it's 5 the limit. So if you can survive deleting one of the other ones, please. Yeah, I think 5 is the limit. So just click on one, go to settings, and scroll all the way down. There is a delete app there if you can afford that. Hopefully you can. Just delete and type the name of the repository, and that's it. Well, you get 5 deployments for free, right? I mean, Facebook made a lot of money just with Facebook. Eventually, they bought Instagram, but they only have the one app making the money. All right, so everybody's ready to go. Okay, here's the steps, okay? Everybody with me. We're going to switch this to use Postgres. So we're going to make a few changes, a few parts, a few moving parts. Okay, resources. First step, we go to resources, go into add-ons, and look for Postgres. Heroku Postgres, right there. The free version, click provision. That's it. Now you have a Heroku database. But we're not done yet, of course. But what's important is that now your application has Heroku wired up to it, so we can use it, okay? Now, the next step is we're gonna go into the settings, reveal config bars, right there, okay? And magically, without us doing anything, magically, this environment variable just showed up there. Database URL. So this is a string that's going to give you information on how to connect to your Heroku SQL, PostgreSQL. So I'm going to copy this, okay? It's an environment variable that they created for me automatically. I'm going to go back to my code, right? Because we need to use that. We need to teach our server now, how can I connect to Postgres by using that environment variable. Cool. As a matter of fact, we could stop the test and all that because it's not important for this step. For this step, what's going to be important is that we need to push our changes to update our code on GitHub, right? So we're going to be writing some Git commands in there. Now, the place where I pick which configuration I'm using or where I configure my connection is in the next file. We pick the configuration that we use on dbconfig, but where I wire that connection string, it's right here. See this connection object. By default, on Heroku is going to look for a key called production, if we have it there. Not for the database, but the application is going to run on the production environment, right? So we know that we have this value that we copied from there, this database URL. And this is how we teach my application how to connect to Heroku. So let's go and create a configuration here that is special for production. I'm going to say production. And of course, the production is going to have a client. And there are different clients for Postgres. We're going to use one called PG. And then the connection, and here's the magic. This could be an object or a string. Turns out that this baby right here happens to be a string, right? So we could just say, hey, I want you to go on into the environment and find me that DB database URL string and use that. So I'm going to call this production DB connection string. And I'm going to define it up here. I'm going to say I have this production DB connection. DB connection is going to be equal to process.env dot this. That's what it is. Cool. But in some cases, and we're going to protect against that, in some cases, if you don't have it and it's undefined, this is going to kind of blow up on you and say, I don't have it, like when running locally, I don't have it, so it may run into a problem. So normally what I do is I create like a fake instance, like const local PG, like pretending that I have a local Postgres instance here, and then I pass all of the configurations that you need. You need the host. It would be local host if I was running something locally here, and then it needs the database, and I would say it would be hobbits, and it's a user that could be student, and then it's got a password that could be hired. Okay, so this is my local PG. So just to trick it, I say, look for that. And if you don't find it, just use that object. It's not going to spin up the server anyways, but at least it's not going to give me that error that I get sometimes. So local PG. So that's the point. The idea here is we know that Heroku has this for us. So we're going to say for my connection to my production database, I'm going to use that if I have it. If I don't, I'm going to try to use this. Okay. And this is going to keep next without freaking out because it's going to find one of the two. Plumbing code. Now, I also want to have some data eventually. And the thing with databases is the SQLite database is going to get created automatically if you don't have it. But in the case of databases, though, those tables don't get created automatically. You have to run a migration in order to create them. Okay. So I'm going to use the same migrations that we use locally inside of these folders. We're going to use that to run the migration against the Heroku database to generate that table, the hobbits table that is not there. Questions there? So again, let me give you this code to save your time. This is plumbing code, basically, every time you're working with Heroku. And then you're going to add this key to your next file. Okay. Again, plumbing code. You don't need to remember. You need to remember that you have it on a project and just copy it from there. This is a fake credentials. This is just, if you were running Postgres locally, you are going to have a username and a password, right? Because those servers require username and password. This is just to keep Next from freaking out and say, hey, you're giving me an undefined for the connection. That's all this is doing. This is fake, kind of a fake object that would be to simulate a local PG connection object. That's it. I'm pretty sure you could just do like an empty string here and it would work, but I want you to have like a sample case of using a database that you need those 4 things to connect to one. All right. Now, I did make these changes. I don't know if my server broke, so just in case, let's do yarn server to see if it doesn't break anything. Oh, yeah, it should break though if we try to connect to the database because we haven't installed the PG client. So let's go and install it. Yarn add PG. This is gonna be in a production dependency. This client right here. We haven't installed this client. Cool. All right. Now I think we should be safe now. Let's go try it out by how can I refresh my application on Heroku so that it sees the new changes? PG is the client. PG is the driver to connect to Postgres. Remember that when you're using SQLite 3, you use this particular little software that we installed, this npm module. To connect to Postgres is different. To translate from Next code in JavaScript to the correct SQL on Postgres and communicate with it. But actually, this is more for the communication part. Yeah, so we need to commit our changes. So commit adds production of, I need to message this. Adds production db config. All right, and git push hobbits. In my case, in your case, it's probably gonna be origin master. Let's see if that's making it to my repository. Adds production db config. So Heroku, if we go to overview, should probably pull that up. There it goes. It's running. We're not done yet. Okay, we're not done yet. I just want to make sure that I didn't break anything by doing this. So remember, to yarn RPG. In deployed. All right, let's try it out. See what happens. We're not done yet. Again, yeah, cool. Notice that we're not using that production key yet, even though it's here. Like if we go back and we go down settings, we have the config bar, it's there and it's reading it from there. Only that it's not. Okay. Any ideas why? I promise we're almost done. Missing like one simple step. Yeah, still reading development, right? Even though now we have the server, we have that key, and we can connect to Postgres, hopefully. We'll see when we do it. Still reading development. So we need to point, we need an environment variable, right? What is the environment variable that we needed? Let's see, dbconfig. Let's open this file here. We need this db_env defined in, not that, defined. Where? Where can I define this? Where should this be defined? If it is on the .env, it works locally. But if I want it to work when it's deployed, I need to go back there, right? We need to go to Heroku and say, please work, please work, please work. And then you change it, right? That's, you remember that, please work. So in here, I need to define this. And I want to say my application, hey, I'm going to point you now to production instead, so that you no longer read by default that development key. I'm giving it the environment. Click add. Okay, now we have this pointing to production. That production in turn is going to go into the next file and read this key right here instead. And this should be pointing to our database URL. Cool. All right. So let's refresh. Uh-oh. Errors. It's going to time out. That's what's going to happen. I'm not going to wait. Just so you know, you see it's still spinning and spinning. It's going to time out. The reason it's going to time out is because we're reading from a DB Hobbits table that does not exist. Our database is totally empty, so we need that table. Yeah, here you go. Time out. So if I have an empty database and I want to add some table, how do we do it the next way? We need to run the migrations. So let's go and do that. Okay. All right. Now, how do I run migrations? Well, normally what I do is I do something like npx, you know, and then next, and then migrate, and latest. And that should work. Locally, though. But if I want to work with Heroku, Heroku has a CLI that we need to install, or we could just run it from npx. So the command now turns into, hey, Heroku, I want you to run this particular command, but Heroku is going to be like, well, you have 5 applications here. Which application do you want to change? So we need to pass a flag to that saying the application that I want to work with, Heroku, is, what do we call it? Luis Hobbits? Luis Hobbits. Let me see. Wait. Gotta check the name. Sorry. Luis Hobbits, right? So this is what we want. So again, Hobbits. In order to run migrations on Heroku, we need to use the Heroku CLI. You could install it globally if you want, but you don't have to. You could say npx Heroku space run, and then pass your regular command, and then at the end, we're gonna say -a and the name of your application. And this is where the default to production is gonna come in place. Heroku is gonna default to looking for production in order to know what it needs to do, where to go and find the migrations and all that. So if we run that, it's gonna look for the migrations in the data folder. Oh, by the way, when you run it the first time, it's gonna ask you for your credentials, and it's gonna catch them on your terminal, so it's not gonna ask you after that. But the first time around, it's gonna ask you, hey, give me your GitHub credentials, your password and stuff. And you see how it defaulted by, this is Heroku, right? You could change that, but it defaults to production. So by having this be the production key, it knows to find the migrations in the data migrations folder and where to find the seeds if we wanted to do that. Let's try that now. In theory, the table should now exist on Heroku. So let's refresh, and we have success. And the way that I measure success is when I have square brackets as the measure of success, right there. All right, it's your turn to go and run the command. I'm gonna give you the command here, right? So you have it. All you have to do is change the name of the application, right, to be yours. So of course, if you got an error that says the client is not provided, then you probably should provide the client and make sure that you add the package to your application and that you commit to GitHub. Otherwise, GitHub is not going to know that you have, Heroku is not going to know that you installed this new package in it. So this bears a review. I'm going to take a minute or two to let you, like a minute, for you to kind of catch up, try and run the migrations. You're going to run into some errors, and then I'm going to do a quick review of everything so you could check, double check that you have everything wired up. Can we sit to Heroku? Of course. All we need to do is change that command. So instead of using migration latest, we do seed run. So I could say seed run. Hit that. And as soon as it finishes doing it, we could do on refresh and we'll have 4 records in there. But this is coming from Postgres. Okay, I'm gonna do a quick review of all the steps involved so they stay in the video, okay? First, we went to Heroku, created our app, wired up to be deployed from GitHub. We know how to do that already, okay? And then the critical step is we went into resources, right? Did a search on the add-ons for Postgres and selected Postgres SQL, this Heroku Postgres here. By adding it and it's showing up down here for you, that automatically and magically added these settings on the config bars pointing to the database URL. So you have a database now connected to your app, and you can get access to this environment variable. If you don't have this environment variable, it is because you haven't added the Postgres database. Now, after we did that, we need to go and change our next file to use the database URL environment that we have now. It's going to be in our process.env. So we added another, let me close this so we have more real estate. We added a production key down here that uses as the client another package, not SQLite3, but PG, that knows how to talk to Postgres. And then as the connection, we are passing this production DB connection, and it's just reading from the database URL variable on the environment. And again, plumbing, we provide like an alternative object just in case we ever want to like have a local instance of PG. All we need to do is change the values of the database, the user, and the password that we want to use. And this is also going to prevent errors from next. The rest is going to be similar to what we have on the development and testing. So the same migrations folder and the same seeds folder so that we know where to find the migrations. Cool. Of course, if we're going to be using this npm module, we need to add it. So make sure that you add that PG module to your application. Once you do that, now you're wired. Your application is modified now to be able to use that database URL on Heroku. So the next step is we do a commit and we push. So that your GitHub does the latest version of your application and knows how to talk to the Heroku database now. And we're almost there. At that stage, we're almost there. Now the next thing is, how is Heroku going to know that it needs to read the production key when talking to the database? Well, that's configured in dbconfig. In dbconfig, we are defaulting to development. So what we do is we change that. By adding in Heroku, we add this db_env environment variable. So that the application, when it's running on Heroku, can read and make this be production so that it goes and reads this information to talk to the data. So the next step happens on Heroku, not on your code anymore. You go into the settings, config bars, and then we have this db_env pointing to production, to the production key. Okay, so at this stage, the application is ready to go, only that we don't have the table yet. We don't have the Hobbits table. So we're going to run a migration on Heroku in order to create a table on our database. And then this is where the other command comes in. This command where we say, hey, npx Heroku run next migrations, the one that we have on here, migrate latest. And then we pass this -a flag to tell Heroku which application do we want to run those migrations against. So you pass the name of your application here. Running the seeds is just as simple, right? All you have to do is change that to be run seed and seed run instead. It's going to ask you for your credentials one time. Just enter your Heroku credentials and then it works. After that, and you should have no errors. If you want to use Yarn instead, yeah, as long as you use that, what is it? Yarn, I don't remember what the command is for that. Yarn create, I don't remember. Yarn npx is good because it catches this without having to install it globally. Because actually what you're doing is this, you're using the Heroku CLI in order to run that command. So you either install it globally somehow or run it with something like this. So why didn't we use Postgres locally in the first place? Because you need to install a server and know how to manage it. This is not a database class. This is a development class. So installing a server locally is not as simple as we would like. And then you have to go and manage security, create users, create databases. So that's not the scope of the Web API class. We don't have a database administrator class yet. If you're interested in learning how to do that, we don't have it yet, but probably will in the future. So now you have both worlds, okay? Really light database that you can use during development and testing, but then when you move to production, if you need to use a server, here's a way of doing it on Heroku. The publishing and all that would be DevOps. The spinning up and installing servers and configure them with security and all that for database would be DBAs, administration. So that database administration. And then the rest is us, developers. Just use it once all of that is configured. All right, so that's it for me. I'm gonna stop the recording here. Have fun, go and play around. And this is why I'd said, if you're done early with the testing, maybe you try deploying, making sure that you could do that with Postgres. I'd love to see you do that because you're probably doing that in labs and possibly next week on Build Weeks. I think you will do it in Build Weeks. So stopping the recording here, but I'm going to stay on this Zoom to help people troubleshoot errors that they have. But we just don't want to make the Zoom too long. So see you.